Hey guys, it's our part 2 of doing the CSES problem set. It will be a 1 hour video. We are starting from now and we'll try to do as much as questions we can. So today my sound will be more clear as I'm using a microphone. So let's start with the questions. Okay. So up to 2 nights we have done this. We will start from 2 sets now. Let me open it in a new tab. 2 sets. Okay, so your task is to divide the numbers 1 to n into 2 sets of equal sum. So the only input line contains an integer n, and print yes if the division is possible and no otherwise. After this, if the division is possible, print an example of how to create the sets. Like firstly print the element in the first set followed by element in the second set in a separate line. Okay. So if the input is 7, it is given that we can partition it, and first set will have 4 elements 1, 2, 4, 7. Second set will have 3 elements 3, 5, 6, and these both sets have equal sum of the elements. Okay, so let's go with it. Let's form the new file for it, which is 2 sets. Okay, so what we are given is that we are given with a number. Firstly, okay, we are given with a number, and see, I have done this today, that it will not suggest us now. Okay, I have solved this problem. So now we are given with this number, and now what we need to do is let's do this. Okay. Okay, so now what we need to do here is we have to divide the set. So 1, 2, 3 up to n. First thing is what is the sum of all these elements? It is obviously n times of n plus 1 by 2, and if it is odd, then obviously we cannot partition it into sets whose sum are equal. Okay, so first condition is itself this, that we cannot do it if the sum is odd. Okay, this is the first condition. Now up to 3 or even up to 4, this thing is simple, that if we have the n as 4, see, if it's 1 or 2, we cannot obviously do that, right? Yeah, the sum is 1, we cannot do that. If it is even 2, we cannot do that, right? If it is 2, if n is 2, can we do this? We have these 2 elements, we cannot, right? We cannot. If it is 2, okay. So now what we have to do is that for n is equal to 3 we can. Okay, if n is equal to 3, we will just do this 1 and 2 in one set, 3 in another set. If n is equal to 4, we can do this 1 and 4 in one set, and 2 and 5 in another set, 2 and 3 in another set. Both will have the same sum as 5. So this is the basis of our solution. Okay, yeah, this is the basis of our solution. So how will this form a basis to our solution is that we will do what is if there is anything greater than 4, if there is anything that is greater than 4, we just have to check if it is divisible by 4, because what we can do is that In case of any four consecutive numbers, let's say 5, 6, 7 and 8, a set can be formed. And how is that? This is the first and the last element and the middle two elements. They will always give the equal sum. Even if we take 6, 7, 8, 9, then we know that 9 and 6 are 15 and 8 and 7 are 15. So we have to group them all in four numbers, like four consecutive numbers sets. Okay, so if n is equal to 5, let's just say, firstly the sum should be divisible by 2. Okay, if n is 5, and the solution will be no, because 5 into 6 by 2 is 15, so we cannot partition it. If n is 6, can we do this? 6 into 7 by 2, again we cannot do this for 6. If n is 7, let's say, can we do this? 7 into 8 upon 2, that will be 28. So yes, we can do this in case of 7. Now how will we do this in case of 7? Is 7 divisible by 4? No, it's not. If it's not divisible by 4, see, if the number is divisible by 4, let's say 8 is divisible by 4, 8 into 9 by 2, the sum is obviously partitionable. So if it is divisible by 8, then we can take what? 1, 2, 3, 4 we will take separately. Okay, and then rest of the numbers, whatever they are, we can run a loop for how many times? We can run a loop for 8 by 4 minus 1 times, because in this case we will, let's say this is equal to 1, right? 8 by 4, 2 minus 1, we will run the loop one time, and in that one time we will solve the thing for all those remaining numbers. 1, 2, 3, 4 is already statically done. Okay, we will solve this for this. If let's say n is 12, then we will run the loop 2 times, because 12 upon 4 minus 1, we will run the loop 2 times. Okay, so let's say if it is even an odd number, we will just run the loop n minus 1 by 2 times. This is how many times we will run the loop, n minus 1 by 2 times. Okay, so what will n minus 1 by, sorry, n by 4 minus 1, n minus 4 by 1, 4 minus 1, or we can do this as 8 minus 1 by 4, n by 4 minus 1. Yeah, it will result the same. If it's 6, if it's 15, let's see, no, it won't. 16, if it's 17, yeah, we can do this, that we can run the loop 0 to n minus 1 by 4. This much times we will run the loop. Now what's the concept behind this is that, let's say n is 7, yeah, we were talking about this, n is 7. If it is not divisible by 4, we have to, after 4, at max, after 4, whatever numbers are remaining, 5, 6, 7 in this case, we have to partition them in group of 4. But as we can see, after 4 there are only 3 numbers, 5, 6, 7. So we will include 4 in this, and we will do the static thing for 1, 2, 3. For 1, 2, 3 we can obviously do this, right? 1 and 2 in one set, 3 in another set, and then we will take 3 in another set, and we will take 5 or 6 in this, and 4 and 7 in this. Or we can do inversely, we can do anything of right? We can take 4 and 7 in this one, 5 and 6 in this one. This will give us the answer, right? So after 4 at max, we have to group everything in groups of 4, and if it's not possible that we can group them in 4, then we will take 4 also there to make it a group of 4, and we will divide 1, 2, 3. And if it is a 8, let's say if it is a 8, then after 4 what are the numbers? 5, 6, 7, 8. These are a group of 4, so we can work with it. So we will do the static thing for 1 2 3 4, that in one set we will do 1 4, and in one set we will add 2 and 3. Okay, so what's important is we form a groups of 4 numbers. See, this will automatically be done because whatever numbers, if the sum is not divisible by 2, we will already discard it. If there are numbers like 17, if n is equal to 17, 17 into 18 upon 2, we cannot do this. If we, let's say 18, then 18 into 19 by 2, it will again be cannot be done. If 19 can be done, right? 19 into 20 by 2, it will be 190. So yeah, we can partition it. So let's see how we can partition the 19. So after 4, how many numbers are there? 5 6 7 8 9 10. 6 numbers are these, plus 9 from 11 to 19. So 15 numbers are there. 15 numbers are there from 5 to 19. Can we can we group them in groups of 4, in subgroups of 4? No, we cannot, because there are only 15 numbers. We require 16 or 12. So we will do what? We will include 4 in this. So 4 to 19 will give us 16 numbers, and here we can make 4 groups of 4 numbers. Obviously dividing in them in different sets will be so easy there, and 1 2 3 we will keep them in different set, 1 and 2 in one, and 3 in another. So yeah, this is the concept behind it. So let's start coding this. So what we have is, if n times of, today there will be no suggestions, okay, so n times of n plus 1 by 2, if this thing n to n plus 1 by 2, this is the sum of first n numbers, is a odd number, then we will just do what? We will see out no solution, right? If we have no solution, let's check. So we will have to print no. Okay, we'll print no, and we will just exit from here. Okay, but if this is not the case, then the sum is even and we can partition it. How it is still showing us? Okay, so now what we will do is that we will take 2 vectors which we will be storing like 2 sets. Okay, so we will just take 2 vectors, that is vi, v1 and v2. Okay, and oh man, and what we will do is that we will take a variable int j. If n is divisible by 4, not divisible by 4, then it will be 3, else divisible by 4, then it will be 3, not divisible by 4. Okay, and if it is divisible by 4, then we will have j as 4. Why are we doing this? We will understand in a minute. Okay, so firstly let's do that. Like if j is 3, we know that we have to partition what? v1 dot pushback to 1, and same for, okay, we will do what? 1 and 2 in one set and 3 in the other set. And else if j is 4, what we need to do is simple, that yeah, let's just do this. Okay, So what we can do is we will just 1 2 3 4 for the four numbers. Two we will push, two numbers will push in the second. So 1 and 4 will be pushed in the first, and 2 and 3 will be pushed in the second, right? Now if this is done, let's start with the main thing, the grouping of the fours. Okay, so we will run a loop for int I 0 to I less than, how many times we will run the loop? We have discussed it, n minus 4 on my 4 times I plus plus. Okay, this will be like, it will take 4 elements at once. Okay, so what we can do is, okay, so now we have to push 4 elements, we know that. So v1 dot push back something, and we will just do the same thing 4 times, 2 times for v2. Okay, now what we will push back is, one thing is simple, that 4 times of I is, we need to do it, but what will be plus inside it, that will be the main thing, and that will be what, j plus 1, right? Whatever we have here, 4 into I, let's say when we have n is 7, okay, n is 7, then this will be the case which will be eligible. Okay, so 1 and 2 in one set, 3 in another set. Now we will come here, n is 7, 7 minus 1, 6 by 4. This loop will run only one time. Okay, that one time we know that I is 0, so 4 into I, it will be 0, so j is 3, so 4 will be at one place, and the rest of the things can be the same. Okay, d. Okay, and we can remove this. So j plus 2 will be 1, so j plus 4 will be 1. Okay, and 2 and 3 will be grouped together. So if j is 3, 3 plus 1 and 3 plus 4 means 4 and 7 in one set, and 5 and 6 in another set. It will be done. Like, let's say now the number is 12. Let's say if it is 12, then this condition will be eligible, and this loop will run 2 times, because 12 minus 1, that is 11 by 4, and that will give a floor value of 2. So I is less than 2 means this loop will run 2 times, 0 and 1. When I is 0, it will cover 5 6 7 8, and when I is 1, I is 0, it will cover 5 6 7 8, and when I is 1, it will cover what, 4 plus 4, 4 plus 5, 4 plus 6, and 4 plus 7, means it will cover 8 9 10 sorry 9 10 11 12. Okay, so 4 plus 5, 4 plus 6, 4 plus 7, and 4 plus 8. Okay, it will cover 9 10 11 12. So yeah, this will be done. So now what's the format of our output is that we have to firstly print the length. If it is yes, then we will print a yes. Okay, if it's not no, obviously it will be yes. So we can print the cout yes here firstly. After that, what we can do is, okay, now if we just return, I don't think it will let us do that, because what are the constraints? The constraints are 10 raised to power 6. Okay, and we have to print the result as a modulus, and we cannot, like, if n is, let's say, 10 raised to power 6, okay, 2 raised to power 10 raised to power 6, and then we cannot do the modulus. Okay, so that's a problem here, so we have to go step by step. Okay, So how can we go the step by step is that we can do one thing. We can start a for loop for I to n. Let's do this. Event answer is initially 1, and we can run the for loop for I to n. Okay, and in the just we will take a number as an input, and we have to find that and its factorial how many zeros are there. Okay, and we will just count the 5s. Okay, so what we can do is, okay, we will just take int n cnn. It will be just n by I. Okay, n by I, because it will automatically take the only integer value of it, because in C++ if like variable is integer, it will only store integers. So we will just see out the answer and handle. That's it. Let's check for input 20. Okay, we already know that the answer will be 4, but still there might be some kind of syntax mistake that we're missing, but it's not here. So yeah, we are done with it. Let's submit this. See, in some questions you must have a knowledge set. Okay, if you do not have the knowledge about this, it will take you a lot of time to decode like what could be the approach for this. If you know that the number of trailing zeros in a factorial only 5 matters, then you can do it easily. But if not, you will take a lot of time to like decode the thing that on what things the zeros will matter. Okay, so this is the thing that we don't have to be demoralized if we are doing something and we are not able to do that, because sometimes it all depends on the knowledge set you have. If you do not have knowledge of this, you cannot do this simply, and if you can do this, it will take a lot of time. Okay, so that's not the problem. So look at the question, try to think about it. If you not, try to gain knowledge about that concept, so that from next time you can do those things easily. So that's the way I do. Okay, now next is the coin piles. That's a pretty like famous question. I have come across this a lot of times. So you have 2 coin piles. Oh, what's the time? How much time do how much time did we have it took? I don't remember. So it is 2 hours. Is it? I don't think so. Or is it 2 minutes? I don't know. Okay, I hope so. Let's see if there are any recordings in here. Um, 145, 825, 28, 29, 217, 218. What is happening? Why they are breaking up like this? 15 minutes, 20 minutes video, then it's a 3 minutes video, then it's a 1 minute video. I don't know. Yeah, maybe. Yeah, I think there's a problem we have. There are hotkeys here. Split recording file. Maybe something from here did this thing. I'm not sure. So okay, I will merge the videos anyways. Let's try doing our questions. Okay, so we have a 2 coin piles containing A and B coins. On each move you can either remove 1 coin from left pile and 2 coins from the right, or you can remove 2 coins from the left pile or one coin coin from the right pile. Okay, so we will take 3 piles out of the both the piles at one time, 2 from one, 1 from one. Okay, we can take 2 from any of them and we can take 1 from any of them. We cannot do that. We take pile from only one and we are not taking it from another. We cannot do that. We have to take only this way, that we have to take a total of 3 piles and at least 1 from any of it. So the first line we'll have test cases, and then we'll have the pile counts we have. Then in one pile how many coins we have. So one thing is simple, that let's say first pile has A coins and second pile has B coins, and we are taking out 3 coins at once, and it should end that both piles have 0 coins. So for this to happen, A plus B must be A plus B must be divisible by 3, right? If it is not divisible by 3, then answer is obviously 0. The answer is obviously no solution, right? There will be no solution for that. Yeah, right? No, we will print a no for that. And else, what other conditions can be there is that let's say if 2 and 2 are here, 4 is not divisible by 3, we will not even consider. 2 and 3 will not, 2 and 4 are there obviously. Let's say this, it will take 2 coins from this, 1 coin from this, and then we will have 1 coin from again this, 2 coin from again this, we will have 0 0. Okay, let's say we have 2 and 7. The sum is divisible by 3, but can we take the coins? Let's say we take 2 coins from this, remaining will be 5, and 1 coin from this, remaining will be 1. 2 coins from this, remaining will be 3, 1 coin from this, remaining will be 0. Now we can not take out any more coins. So the thing is that we are taking 1 coin from one and double coins from another. So any pile must not have the coins less than half of the other pile. Okay, if A is greater than B, let's just say, then B must be greater or equal to at least A by 2. Okay, if B is less than A by 2, or alternatively we can say 2 times of B is less than A, or 2 times of A is less than B, then we cannot divide them. Okay, there will be no other conditions, because all in any other cases it can be done. If we take 4 and 5, it can be done. That if we take 1 from this, it will 3 be remaining, it will be remaining 3. And now in case of 3 3, obviously we can do 2 from this, 1 from this, 2 from this, 1 from this. Okay, so these are the only conditions we have. So let's try to code it now. Coin piles. I don't know what happened to my recording today, but it's making me worry about it. Anyways, coin piles dot cpp. Okay, now we will take the test cases. Now we have both is, if both are 0, A is 0, A is 0 and B is 0, we will just simply say yes, right? In that case, when both are 0, we will just say yes, cout yes, that both are already 0. We have to make sure both piles have contain 0 coins at the end, and we will just exit from our code, exit from our execution. And if they are not 0, then, and now we will put yeah, I guess that's correct. Let's test it out. Yes, no, yes must be the output of this code. So let's remove these codes and run this. For this input, yes, no, yes, yeah, we are correct. And let's submit this. It will be coin piles, and we will submit. Yeah, it's done. See, our recording is again like broke out in between. I don't know why, but it somehow did. And yeah, 218 to 226 we have a recording again. Well, let's see what's the problem later. Okay, let's move to the next question for now. There's the palindrome reorder. Okay, we started at when? I guess 145, right? 145. Okay, we started at 145. We still have 15 minutes. Let's see how many more questions we can do. So we are given a string and your task is to reorder its letter in such a way that it becomes a palindrome. Okay. We are given a string and we have to check it. If we reorder it, it can be a palindrome or not just we check it, we have to return the palindrome string also. Okay, so if we copy it and paste it here. Okay, if we have this string, firstly for every string we will take two conditions. If it's a odd length or it's a even length. Okay, now get into the details. We will take a map, and for every character we will count its frequency. If its frequency is even, if the number of elements whose frequency are odd, we will take them as count. Count represents what's the number of elements with a odd frequency. If this count is odd, means there are odd number of elements with odd frequency. Even not that. Okay, what can work for us is if there is greater than one element with the odd frequency, the palindrome cannot be created, right? If there are more than one element with odd frequency. If there is only one element with odd frequency, let's say if count is 1, and it's a even length string, then also we cannot create a palindrome. And if count is 1 and if it's odd, then it can be created here. Okay, for even, the condition is that every element should have a even frequency. C must be 0 here if it's even. Okay, and if it's odd, C can be only 1. If it is greater than 1, it will just return 0, no matter if it's odd length or even length. After that, we can just do it right we will take a string and up to half frequency of every character we will insert in that string, and we will just reverse that string and append it into it. If it's a odd, then we will, this C is equal to 1, we will keep track of this character. We will put C in between, and in this case there is no in between character. We will just get string, reverse it, append it and return it. Okay, so it's a that kind of question, so easy it is. So recording is going on, right? 4 minutes. Okay, let's start doing this. Palindrome reorder cpp. Okay, now for this string let's have a map that will be character to integer mp, and for char C of this string, we will just do MP of this S plus plus, not this S actually, MP of this C plus plus. Okay, and we will take a char CHR. Okay, we will take a character CHR, and if now we will check after this, remove this indentation. Now we will iterate through this map. Okay, now we will iterate through this map, auto IT of this map, and we will take a count. Now not go, we will iterate the map now, and in this map second string will be S2 will be str plus, no, we have to reverse this string, right? If we are putting it here A B B, then it must be B B A, right? The reverse of that string. X of MP. Okay, we can do this. Str plus S2. See, what it will do is, let's say first time only A's are coming. Okay, A are coming, so it will be AA S1, and S2 will be also AA. Okay, now BB, next time B is coming. B are 4 times in the input string, then S1 will be like this, BB, but S2 will be STR plus S2, means STR is BB, so BB plus AA. So that's what we want, right? So it will be like this, and just put Cout S1 S2 and L, right? That will do the thing. Let's try this out for this input. Okay, the output must be AAC ABA CAA, AAA CBCAA. Yeah, doesn't matter, in any format we can return our answer. There are 6 A's, so 3 A's, 3 A's, so yeah, that's fine. So we'll just submit this. They can be multiple palindromes, right? It's not fixed. Submit it. Yeah, it's accepted. Let's go to the next question now. It will be the gray code. Is our recording doing fine? Yeah, it's again started. Whenever I submit a question, it restarts. I don't know why, but it does. I don't have an idea why it's doing this. I will track it next time on another screen. Okay, so we have a gray code is a list of 2 key power n bit strings of length n, where any 2 consecutive string differ in exactly 1 bit, means the Hamming distance is 1. Okay, if we are given an n 2, we can have 2 raised to power n strings, right? We did a question earlier. So if 2 raised to power 2, 4 binary strings are possible. And a gray code is something when the 2 consecutive strings have a Hamming distance of 1, means they have only 1 character or 1 position differing, like only 0 and 1 differs. In these 2, only 1 and 0, these first position differs, and in these 2 only second position differs. So this is the gray code. So we need to make something like this. So how can we make this is, we will, let's say we have a vector, we will be returning our answer, and initially we have an empty string here. Okay, we have an empty string, then obviously we will take two string at one time. So n is equal to, let's say, 2. So in the first iteration we will take these two strings, two empty strings, and we will do what? If there are two strings, then in one I will put a 0, in second I will put a 1. Now I will duplicate this to be like this last element comes here and this next element comes at the next position, or the first element comes at last. Now again I will do another for loop, and I will divide into two elements here, two elements here, and I can remove this partition. Now I will put 0 in all these elements and 1 in the second half, 1 and 1. So we can check that 0 0 1 0 they are valid, 1 0 1 1 they are valid, and 1 1 0 1 they are valid. We are good with n is equal to 2. When n is 3, let's say, we are starting with an empty string. So we have these two strings. Okay, so at the first iteration 0 will be 1 and 1 will be here. In the next iteration it will copy and there will be 4 strings. Now what will happen? In the first half we will just put 0 0 and 0. The second half we will put only 1 and 1. Now it will make a copy of these 4 strings and in reverse order. So it will be 0 1 1 1 1 0 and 0 0. Now in the first half, these are 8 elements, right? In the first half we will only put 0 0 0 0 and 0. Second half we'll put only 1 1 1 1 and 1. Now check the Hamming distance between any two consecutive strings. Valid 1 0 0 1 1 0. These two valid, only first element differs. For these two only third element differs. For these two first element differs. For these two second element differs only, and for these two only the first element differs. So yeah, we're good with this approach. Let's try to code it. How can we do it? The name of this question is gray code. Shortcut, man, why are we going with this? So we will run the loop and type answer dot push back the same string, means answer J, right? Okay, and once we are done with this thing, we will go to the next loop. We will be running this loop from j to j less than. If the answer is this, now the answer has a double size, right? So answer dot size obviously it will be, but for first half we have to do something different. So if j is less than answer dot size by 2, we have to do what? We have to answer j plus equals to 1. Okay, it should do the thing. I guess it should. and when we have the answer we have to just print the element of it. So for I to answer dot size, we have to do just this, that we have to print answer I and oh no, we have to print out this. Okay, we have to print in different lines. Let's try running this when I is 2, input is 2. When the input is 2, why is our code not running? T n answer dot pushback. What happened, brother? Okay. Okay, it's going in some infinite loop, I guess, but we are doing it for this. Yeah, I guess it's going in some infinite loop, that's why it's not running. But what's the issue here is we're taking it I is the outer loop. Initially it will run only one time, so let's say n is 3. I will go and okay, I guess I get it, because we are inputting answer every time in there and we are checking the answer size here, right? So it's a never ending loop. We are inserting an element and we are expecting the loop to be ending by decrementing it here, but the answer dot size keeps increasing. Okay, so we have to take a variable at the start which will be answer dot size, and we have to put as z here. Okay, and then we don't have to put it here. Yeah, it should run, I guess. It's fine. So at the second place it's fine. Again, it's something is wrong there. So yeah, that's fine. We can do one thing, that we can just do this and we can do this and this, right? It should be fine. Segmentation fault. j plus plus, if j is less than this we have to do this, else this. Square 2, so answer is pushback answer j. We dot pushback be j, right? Okay. Oh, that is pathetic, man. Shut up. Yeah, we are good now. Actually we were confusing it because there was I written here and we were expecting it to be j, so that is fine. We'll choose this file and gray code, open, we'll submit it. Yeah, we're good with it. Okay, so it should be restarting. No, it doesn't actually. That's good, but yeah, there are a lot of recordings today because it just broke out. I don't know why, but see, there are 1 minutes recording. 40 to 46 is fine, but 47, then 48, then 49, and then 50 is running now for 5 minutes. Okay, I don't know why it's happening, but fine, we are good with this. Yeah, that's fine. Yes. Okay, the next question is Tower of Hanoi, and if you don't know about this question, you are really living under a rock, because this is a really famous question and really good question, I must say. The concept here is recursion, and to understand that recursion, it's a really typical job to understand the recursion. We have got 1 hour, we have our 1 hour ended today, so we are gonna end the session right now, but we'll do this tomorrow. And we have done today how many questions, if we can see, 1 2 3 4 5 and 6 questions today. I must have done the Hanoi, Tower of Hanoi, but that's fine. Up to tomorrow we can 1 2 3 4 5 6 questions, so tomorrow we can finish all these questions if we can do this. Obviously we'll try to. So that's a good progress for today, and this will be the end of this video. Thank you guys.